All right, let's look at problem types for forces now. So we're looking at our forces problem types. First type we have is first law. It's a first law problem because one of these things is true. Either as a constant velocity, the forces are balanced, it's in equilibrium, the acceleration is zero, or the net force is zero. Therefore, if one of those is true, the rest of them are true, and I need to set up a free body diagram and sum up the forces and set it equal to zero. So the because and therefore are a little mixed in there. Second law is kind of the same way. If one of these is true, the rest are true. So because it has a changing velocity or an unbalanced forces, or the acceleration is not zero, or the net force is not zero, therefore the rest of them are true, and I draw a free body diagram and sum up the forces and set it equal to ma, Newton's second law. It's an inclined plane problem because we're on an incline. So what do you do if it's on an incline? Well, you rotate your axis if there's an acceleration. If there's no acceleration, you don't have to. You have to resolve mg if you do rotate that coordinate system. And it looks like this. Okay, so this angle here is the same as the angle here between the new y and the old gravity directions. And you find those components. If it is a multiple mass problem, that means you have multiple masses connected. So the first thing you need to do is identify the acceleration direction for each mass and call that the positive direction. Next, you need to draw a free body diagram for each one and sum up the forces and set it equal to ma. So generate an equation for each one. Now you can link those equations by a common force and a common acceleration. That's why we needed those accelerations to be positive. You should also see that these forces should have opposite signs when looking into these equations for your different objects. Now there's two types of friction here. We have kinetic friction, that's friction with sliding. If you do have friction with sliding, that means the force of friction is a constant value of mu sub k times normal force. If you see that, remember the mantra, substitute, substitute, substitute. And if you do need to find the normal force, you can find that typically in the y direction. Static friction is when we have friction but no sliding, so it's without sliding. In that case, the force of friction can be a range of values, anywhere from 0 up to a maximum value of mu sub s times the normal force. And again, you can find that normal force in the y direction. And our last one in this chapter is Hooke's law. This is when we have forces from a spring or an elastic object of some sort. In this case, we're going to draw a free body diagram, generate our equations, and we're going to substitute, kind of like we did with friction, we're going to substitute in kx for that elastic restoring force. And there you have the problem types for forces.